Good afternoon. Congratulations on making it to the last session of SQL Bits. I am not worthy of your attendance. Thanks very much. I don't think I'll ever make it to this far. So today, what we are going to look at is Docker and Kubernetes for the data scientist, all right? So what we're going to do is we're going to look at a little bit of theory around Docker and Kubernetes, just set the scene. And then we have a ridiculously ambitious demo to get through, so we'll see how far we get. Otherwise, I'll just point you to some other bits and pieces, but we'll see how we get on. Out of interest, who is a data scientist? OK, cool, cool. Who is, I don't know, who's a Docker person? All right, OK, fine. OK, good stuff. So a little bit about me. My name's Terry McCann. I run a company called Advancing Analytics. You will find us over that way somewhere with the people with the grabber. Do come along and try and grab a prize. We do pretty much anything data engineering and machine learning, predominantly on Azure. We do a lot around machine learning engineering, which is really kind of the topic for today. We have a YouTube channel. By all means, go check it out for videos if you like this kind of content, right? OK, so when we start thinking about machine learning, a lot of people kind of get very hung up on the aspect of machine learning, which is actually building a model. And pretty much most people start neglecting what actually happens to kind of keep that model live, put it in production, and get it running as quick as possible. And so there are a lot of dependencies that we need to kind of look at. And what we can do is start taking advantage of something like Docker and Kubernetes to enable us to get accelerated with some of these bits and pieces. So let's start with a little bit of a history on this, right? Where did Docker come from? Why is it here? What is the purpose of us using it? And if you think back to, gosh, I don't know how long ago now, if you were to go to your business and say, look, right, I've built this great application, and what I want to do is I need some kind of server to run it on. What would typically happen, right, is they would say, right, OK, well, how big do I need this server to be? Like, how big? And you're like, I don't know, I just made the app, right? I don't know, this big? And so they would probably over-provision it, or realistically probably under-provision it, because IT teams were cheap. You'd then build your app, right, and you'd put your app on there, and you would have the operating system as well. And so now that becomes quite a lot of stuff and a lot of overhead to kind of manage, right? You've got to manage the operating system. You've got to manage the actual physical kit behind that server. And that's quite a lot of work. Now, when you want to scale that out, right, I've got two applications. What ends up typically happening, right, was that you'd end up just kind of duplicating this. And so you're duplicating all of that effort. And I mean, I know, right, if you were to ask me to be the person to kind of monitor all of this for you, it's going to be the stuff that gets ransomware, because it's just not my forte, right? I'm not set up to try and manage this. And it becomes an awful lot of work. When you keep doing that, right, we just keep scaling and we keep scaling, and the problems just kept mounting. So we needed an alternative way to do this. And so along came kind of the hypervisor, and we started looking at virtual machines. And so with that virtual machine, instead of having a single server per application, we ended up with a server with a hypervisor tier stuck on top. And that gave us the ability to start adding virtual machines to kind of encapsulate our applications. So we'd build out a virtual machine, and we'd put our operating system in there as well. And then we'd put our application on top. And so we reduced the overhead of what we had to manage from a server perspective, but we still had that operating system, and we still had all of the costs. And again, that just kind of got amplified with each application that you tried to deploy. And so with this, there's still an awful lot of overhead. And so what we needed was some kind of service that, that would give us a similar feel, but without the overhead of having to maintain an operating system, without the overhead of having to maintain all of the disks and everything else. And also, right, the duplication of things like operating systems are huge. And that amount of storage space really just, ends up encroaching on how much of your application you can run on here. So along comes Docker, right? And Docker is designed to try to simplify a lot of this. So we start off again with a server, right? But on this server, rather than having something like a hypervisor, we have the Docker OS. And the Docker OS is its own operating system, enabling us to begin to containerize our applications. And so what we do is we take our application, and now rather than having to have the full-blown operating system, we are creating discrete deployable units of our application, which will essentially for us be our machine learning model. And with this, what we're able to do is just deploy more and more of these kind of containerized applications. And we end up with an awful lot of free space as well, because we can put more on here with less amount of overhead. Okay, so Docker enabled us to kind of containerize these applications and limit the amount of exposure we have to things like operating systems and be able to kind of get this running in a neat way. So let's go through some of the key concepts, right? So Docker is all about discrete deployable units of work. Everything that we have should be able to be deployed and replicated a number of times, and each kind of work in isolation. Okay? It's largely driven around stateless processes. So we don't want our Docker containers to have any state. And typically what that means is we don't want to have to store potentially data, etc. Although you can do things like storing data in remote repositories like blob storage or databases, right? We deploy the same environment each time. Now, machine learning models, right, are difficult to deploy, mainly because there are a number of different dependencies that we need to contend with. If you take something like just a basic scikit-learn model, right, you've got to worry about the individual packet of scikit-learn that you're using. If you're using anything else like MLflow or another package, we need to also think about how we encapsulate each one of those dependencies. And when we deploy them, we want to make sure that the environment we trained with is the environment that we're going to score with. Because if we don't, over time we might end up with irregularities, and our models might start performing in different ways. So we want to make sure that we deploy the same environment every time. We want to deploy all dependencies. And Docker supports the idea of cattles, not pets, okay? And so with this, what we mean is that we are expecting these containers to die. We don't want to treat them like pets. We want to treat them like cattle, okay? I'm a vegetarian. I quite like cattle as well as pets, but, that's as far as that one goes. So we know that they will die, and we will bring them back up, and that's okay, right? So Docker, let's have a quick look at this. Right, hopefully you can see that fine. I'll minimize some of this. So what we're going to do is I'm going to open up a terminal window over here. Let's clear the screen and zoom in a little bit. I'm using Windows Terminal. If anybody hasn't used Windows Terminal before, it's very good. I'm not quite sure why my screen is flashing zoomed in. We'll zoom out a little bit. And what we can do is just issue a very basic Docker command. Okay, so Docker, I'll zoom back in a moment. Docker run hello-world. And so what this will do is it'll say up here, it is just Docker checking that Docker is actually working. But what this has actually done is a number of different steps. So when I say Docker run hello world, what I'm actually doing is I'm saying I want you to go and create me an image. I want you to create me a container of the image hello world. Hello world is an actual Docker image, and when I do this, it's just running it. Now, it's a kind of ephemeral image, which basically means that we run it once and then it immediately dies. Okay. So with this, what we can also see is if I Docker, where am I? Hello world. So what I'm going to just do is remove the image here and run that again. And what you'll see this time, okay, is you'll see a few different things happening. So you'll see it's, first of all, unable to find the image locally. And then what it's going to go away is going to go and try and download that image, and then it's going to run that image for us. And then we start seeing this here. So a very basic example, right? But what that's doing is it's going away to a remote repository, bringing that image down, and then getting it running on my local machine. Okay. So let's just talk through some of those concepts. So Docker works by essentially looking like something like this. You have a Docker client, which for me, I was using my terminal, and the Docker host is installed locally on my laptop. Now, when I was asking that hello world image to run, what it's doing there is it's going away to that remote repository. It's going to go and grab an image, it's going to pull it down, and then execute that image. That image will then be run as a container. You can kind of see that image in the middle of our image there. It says images. Each one of those containers is a running instance of that image. We have a main kind of central repository for most Docker images, which comes from Docker Hub. And you can find pretty much anything on here which is underpinned by Linux. So for us, what we're going to look at is using a Python-based image for all of the deployments of our models. And we're going to incrementally kind of build up on top of that. So examples that you've got here, right? We're looking at things like you've got an Nginx image there, you've got an Alpine image, a Redis cache. You've got a number of different ways of working. The other one, the interesting one there to also call out is it on there? You've got this image, Alpine. Alpine's a tiny little distribution of Linux, and that gives us the ability to incrementally just add stuff on top. The images that we will pull from will be published versions of Python. One of the things you have to be aware of with these kind of images is that they can end up being very large because they just contain a ton of information and a ton of packages that we'll never use for our processes. So sometimes it's a lot better to start with a very small Alpine image, put Python or something on top, and then incrementally grow from there. Okay, Docker commands. We'll look at a few different ones today. We'll look at Docker pull to pull an image down from an image repository. We'll look at Docker images so that we can see which images we have running. We'll use Docker build to take a running version of our application and containerize it. We'll use Docker run to run that image. We'll use PS to have a look at which things are running. We'll stop stuff and we'll remove things as we go, okay? If you get starting with Docker, there are a load of great cheat sheets available. I certainly recommend going and having a look at some of these. Right, but how do we create an image from scratch? How does this all work, right? So Docker has a number of key components. So the first thing that you'll have is you will always inherit from a base image. So we mentioned a couple of base images, right, in terms of Alpine or Python. And here it could be something like, as it says there, right, R, or something like a Node.js application. And that base image is what we're going to then just incrementally build upon. From there, we'll have our application and any files that we need. And then we'll also have a Docker file. And it's this Docker file that describes how our application should run, how we want it to go and find things, and what should it actually be doing. OK, so an example of a Docker file might look something like this. So at the top here, this is the Docker file. And it says the first thing we're going to do is we're going to inherit from this base image of Python 3.8-slim. And so that is a kind of encapsulated environment of Python 3.8. And it's using a slim version, which hopefully will ensure that we are keeping it as tight as possible. One thing to be aware of here is this is 3.8, but we're not specifying an exact version. So what we might end up with is 3.8.1, and if we run it again, 3.8.2, we want to make sure that our images that we end up with are super tight to the process that we need. I'm then going to say, I want you to copy everything from my working directory over to this Linux path, because everything we're looking at here is going to be running on a Linux subsystem. You can run Docker for Windows and run Windows containers. Should you run Windows containers? Yeah, probably not. It's still not a great experience. You'll then set your working directory, sort of where your application is going to run from. And then we're going to do a couple of bits and pieces. So it's going to run a pip install, and it's going to run that from a requirement.txt file. So we're going to look at every single requirement in that file, just loop over them and install each package incrementally. And then it says, the last thing, what I want you to do is just run my application. So just run this python app.py. Okay. So running a container. So what we do, right, is when we're doing this, we are creating a Docker image. So as we inherit from that base image, apply all of our application and the Docker file, we will build that out to be its own Docker image. And so we'll build that will become an image. Then we will run that image, and that will become what's known as a container. And we could have hundreds of these containers running. If you think about a kind of machine learning environment, right, we might start off with a new thing. Maybe we're doing something like a recommender system. And we put that recommender system live, and we put it behind some A/B testing on our website, and we let through maybe like 2% of the traffic. And then we monitor what the outcome is of that 2%. And we find that, actually, you know what, there's a massive improvement that we've seen in that small subset. So we start scaling it out, right? We push it up to 10%. When we're at 10%, what's happening there? And we might find then that actually our application is starting to slow down a little bit. So that's that point that we can say, right, I want to get a few additional running containers of this. I want to load balance them and get them scaled out. And in that way, as we start increasing that traffic, rather than showing any kind of hit to our end user, we're able to get that just working, and we're able to scale with the demand that we have. So our running application will kind of talk to that running instance of a container. So adding a container to a registry. So when we're looking at something like Kubernetes, we are going to be looking to build out our own custom image. We're going to deploy that somewhere, that image, to a container registry. And then we are going to ask Kubernetes to run that version for us. So when we want to deploy our stuff, we're going to go through this kind of process, and we'll step through all of this in a demo, and hopefully it'll make a lot more sense. But we're going to build our image. We're then going to tag our image, and we're going to push it up to our container registry. And so what we'll end up with in our container registry is potentially multiple different images, all for the same model, or for a multitude of different models. So here we've got diabetes, and we've got a kind of version 1 of that diabetes Docker image. And then what we've done is we've actually retrained our model, and we've incrementally improved it. So we're deploying another version of that we're going to then use in production. And then we might have something else in here, such as a customer churn example, right? And so once we are here, we then need something to kind of orchestrate that and run this for us. Because as we've mentioned, right, our Docker images, we're going to treat them like cattle and not like pets. And when they die, we're going to need something to bring them back up. And this is really where Kubernetes comes in and certainly helps us out. Yep, thank you. Yep. So what we need, right, is once we've got these things, we need to deploy them somewhere. But where are we going to deploy that? A great option for us is Kubernetes. Alternatives are things like Docker Swarm, but certainly, you know, Kubernetes is far more popular. I mean, pretty much the entire world runs on Kubernetes, right? Most stuff is kind of deployed in that way. So what happens when we've got this kind of scenario, right? We've got a number of Docker images deployed, and then over time, something happens in them, and they start to die, and they start to come down. We need some kind of service that is going to help this and keep this and support this for us. And that's where we're going to start looking at Kubernetes. So Kubernetes, which is apparently Greek for the helmsman of a ship, it runs and it manages containers for us. It does a huge amount of additional things on top of this. But largely, what we are going to look to Kubernetes for is to offer assistance with taking our image, getting that running, and getting it running in production for us. The great thing about Kubernetes is it's multi-cloud. It runs on bare metal. You can run Kubernetes on your local machine. You can run it in Azure, AWS, GCP. With things like Azure Arc, we can connect a whole number of different Kubernetes services together. And we can do a load of great things in terms of having this deployed in one cloud and having it deployed in multiple clouds, all in a very consistent way. It supports multiple container runtimes, and it operates in a desired state kind of way, which is really great for us because what we're able to do, right, is we're able to, rather than say, this is how I want you to run, is we just describe how we want something to run. So I say, I want you to deploy my container, and today I want that to have one replica because we're not running a lot through it. But as we start seeing things improve and increase and demand increase, and then say, actually, what I want you to do is increase that scale to 2 machines. And rather than having to do another deployment or anything like that, we can just change the original desired state configuration, get that deployed, and then enable it to update that and replicate over two pods. And we'll come on to talk about those in a moment. So Kubernetes largely comes from Google. So Google were the original developers around Kubernetes, and it was heavily based around a proprietary system known as Borg. And I think there were original kind of wants and desires to try and open source a lot of Borg. Borg eventually became kind of Omega, which was another internal project, which again looked to kind of be open source, but there were too many tightly coupled dependencies. So what they worked on was this open source project called Kubernetes. But with all of this stuff, they kind of share a central DNA that flows from Borg through Omega into Kubernetes. And Kubernetes has been around for an awful long time now. So it sounds complicated, right? How do we make it a little bit easier? Well, you can always look at, at the lovely Kubernetes story, which you can download from Microsoft, which will take you through all the lovely stories about how pods are developed and also how replica sets are developed. It's all lovely. I used to have a huge stack of them that I just bring around to events to give out to people, but I think they've long been out of print. But you can still you can download the PDF of it, and it's a lot of fun. So the Kubernetes service looks a little bit like this, okay? When we're looking at Kubernetes, it's a scaled out deployment. So we'll have a kind of main node, and we'll have a number of worker nodes. And that main node is largely responsible for being our kind of central point that we deploy to. And then we'll have a number of worker nodes which will act as our ability to give us scale. So what we will do is we will develop a piece of YAML that will describe how we want to deploy our application. And we will deploy that to our master node. And then that master node will replicate our data based on what we're saying, okay? So we might say, what I want is I want 3 replicas. And it will create me a single pod, which is the smallest unit of dependency. And it will deploy each one of those pods evenly across my worker nodes. And then we'll also deploy a load balancer potentially on top of that to ensure that we've got a single point to go through, and then we'll replicate across. Now, when one of these dies, what we have as well is we have that master constantly monitoring what's happening and kind of shifting stuff around for us while we bring up a new node. And the same thing happens with pods. So as a pod goes offline, what we're able to do is there's a service that's constantly checking to say, right, I expected I would have 3 pods, but actually I only have 2. So what I need to do is bring another one back up and ensure that that is going behind that load balancer as well. So what we have, right, is we have our container, and that might be a number of multiple containers all kind of orchestrated together, and that fits inside a pod. And a pod is kind of what we talk about in terms of Kubernetes. And what we'll do is we'll create a deployment for that, and we'll create a service, which will typically be that load balancer. And it's all orchestrated using YAML, and then we're away. So Kubernetes in Azure is all kind of underpinned by AKS, which is the Kubernetes service. And it's great because one of the massive benefits that you get from AKS is it's a fully managed service. It is just available, very easy to get started with. And also, you don't pay for your master node. So you only pay for the individual workers, and you're able to save a little bit of cost there, which is great. In order to deploy stuff under Kubernetes, you'll use YAML, which everybody loves. I've never heard anybody who says they don't like YAML. It's like everyone's favorite language. It's perfect. But YAML looks a bit like this, right? And what you can kind of see is we've got 2 different services here. So we've got a load balancer down here, which is running on port 80. And then we've got our actual code up the top here, which is describing how we want things to work. And you'll see here we've got a single replica. But we could have multiple replicas here should we need them. Right. Let's have a look. So there's a Kubernetes API as well that we'll look at for the CLI called kubectl or kubectl, which is actually Greek for a terminal code window, which is really useful to know. But it's how we interact with Kubernetes, and that's what we will look at. I am going to skip into now a little demo of what we're going to look at. All of this stuff is, I think it's all available on my GitHub, so you're more than welcome to go and grab it. But what we're going to look at is, if I can just zoom this in a little bit more for you. Zoom in. There we go. Hopefully you can see. Is we are going to look at building out a very basic service. So this is using Flask. I'm not sure I actually recommend you use Flask anymore for the deployment of machine learning models. It's quite a lot of overhead where you've got other things that work a lot better, such as Fast API, but this is where we are for the moment. And so what Flask will do is Flask gives you the ability to create a REST service, which you can underpin your model with. And so what we're looking at there, right, is we're looking at providing an API that we can integrate with our application, and Flask is going to do that for us. So with Flask here, we're saying, right, I want to import Flask, and then what I'm going to do is I'm going to instantiate Flask here, which is this bit here, app. And then what I'm doing is I'm introducing a couple of different routes. And so what a route is just a method of kind of accessing a particular layer inside our REST API. And I'm going to put two different interfaces in here. I'm going to put a training interface and a scoring interface. And so what I want to do is I want to give my end user potentially the ability to retrain a model on the fly and then have that new version of that model available to immediately score with. Realistically, you're probably not going to do that because you want a bit more control over what's happening with your model training, but certainly with scoring, you'll want to kind of have this interface. And so with training, all we're looking at here is a super basic flow where we're taking some data, we're splitting it, test and train, we're running it through a very basic linear model, so creating a linear regression model which predicts in some way a propensity for an end user to have diabetes. And then what we're doing is we're just going to return those results back to our end user and say, right, this is our model and this is what we're working with. What we're going to do then is we are going to serialize that model back into bytecode using Pickle so that we've got something that we can productionize. And then once we've got that Pickle model, we'll then be able to start scoring with it, and we can start looking at some results, and we'll send some requests to our server. So if we run this, let's just get out of there. What we can do is if I go and just copy a link to this file, if I hop over into my terminal window, and let's clear this stuff here, and we just run Python, and we run our app.py. This will start an instance of our Flask server. So what you can see up here is it says, we're running Flask, and by the way, we're running it in debug mode. And your application is going to be available on this particular address here. So if we hop over to a web browser, what we should be able to do is we should be able to look at our local host, and we'll run our train. And what we can do is, now this is an instance of our REST API running inside just on our local machine. So we haven't done any containerizing at this point, but each time I run this, what I'm doing is I'm retraining that machine learning model, and I'm getting back the mean squared error and the R squared, the coefficient of determination, okay? I'm also getting back a success. Now, if I want to pass individual values to this model, I'm going to use that other interface, and I'm going to use the score interface. And so what you can see here is, as I change this input, what we should also see is our predictions changing. So if we change this to be, say, 1.2, what you'll see is you'll see that prediction changing as we increase it again to something silly. That's going through, and we're getting a kind of real-time API pulling back. So a very basic example. This is the example we're going to step through. Now, getting this running on my local machine is one thing, right? That works okay for us. But what we need to do is we need to ensure that we're able to deploy this elsewhere and get this running on any machine. That's where Docker kind of comes in, and that's what we're going to look at next. So what we need to do is start thinking about some of those key components. We need a base image, we need a Docker file, we need all of the requirements and everything to kind of connect this all together nicely. So back over in our solution file, what we have over here is we have our application. If we have a look at this one here, we also have this Docker file, and we've got a few other bits in terms of like our requirements file. So if we first look at the Docker file, what you can see is something similar to the example we looked at, right? We are going to inherit from that base image of Python 3.8, and we're going to copy over everything from this working directory. So I'm going to copy over all of these files to my Linux OS, my Docker OS, okay? So I want all my stuff to run. And then going to say I want you to set the working directory to this location. I want you to run a list files purely for debugging. And then I'm going to ask it to start installing all of my requirements. And if we have a look at these requirements, what we'll see is just a number of different machine learning requirements to run this model. So you'll see scikit-learn, and we want 0.23.1. We want NumPy, and we want Flask. And what we're doing here is we're trying to say, right, these are the dependencies that I have for this model, and I want you to limit them to just these individual dependencies. I don't particularly want you to go and get any new ones, because as these packages change, and they all change quite frequently, we want to ensure that we are locking everything down to that single environment. So what we will do here is our Docker file will say to Docker, I'd like you to build an image here, and it will go and it will have a look at this, and it will start incrementally building on top of Python, and it will then install all of our requirements one after another. So let's have a look at how we actually do that. What I am going to do very quickly is just delete some of my testing that I was running earlier, just so that we have all of this. And what we are going to do is hop over again to our terminal window. I'm going to stop the current version of our model running, because otherwise it's going to get very caught up on itself. It all runs on the same port. We'll try and run a score again. And hopefully what we'll see is that our session will just hang for a while, and then it will eventually crash. So we know that we don't have any service currently running. One thing to call out here is that as we go through and build our stuff out, I'm exposing port 5071, which is the default port for Flask. And the reason I'm exposing this is because when we try and run our application, at the moment we've been going to localhost and 5071. But what we'll actually have to do now is we need to be interacting with port 5071 on our local Docker container. So what we'll need to do is a little bit of port forwarding from my local machine inside my running version of Docker. So exposing that just means that we know we're going to be talking to the right services. Okay, let's have a look at this. I will go back here, and what we are going to do, I'm just going to delete my image out again so that we'll start from scratch. And I'm going to remove you. Perfect. So what we want to do is we want to make sure that we're working in the right directory. And you are. And so what we'll say is I would like to go away and start to build an image. So the keywords that we're looking for here, I'll copy them from my notes, is we are going to build this model for diabetes. So if I run this, and we'll talk through what it's doing. You. Brilliant. Hold on. Okay. Perfect. I think because I'm on a different Wi-Fi, it is preventing my access to something. Brilliant. 2 seconds. Let me change this over. Am I in the wrong directory? Oh, I am indeed. Thank you. Right, let's have a little look. And let's point you in the right place. Let's copy this path. And we will change our directory. Thank you very much. And so what we'll do is we will try and build that image now. So what that's going to do, if we zoom in again and have a look, is first of all, blimey, it really doesn't like zooming in today, is what we're going to do is we're going to go away and find that, right? So it's going to load our build definition, it's going to load our Docker file, and it's going to start pulling that stuff in. So first of all, it's going to go away and get that Python 3.8, and then it's going to start trying to incrementally build our stuff on top. It will then start looking to try to add a lot of our packages, and then so what you will have seen here, if it have loaded quick enough, is it have incrementally gone through and installed every single one of our requirement files. Now that we're here, what we should have is, if we have a look at Docker, and we have a look at our images, what we should have is an image called diabetes. And this version of our image here, there we go, diabetes, is what's going to be our image for our model. Now, we don't have anything running, right? If I have a little look again at localhost and I try and run one of these, we're in the same situation. We don't actually have anything running just yet. So we need to get this stuff running. So what we're going to do is we are going to go and actually try and get that running. And so we're going to do that with this particular bit here. Let's go back. And what I'm saying is that I would like to run my version of my model. So I'm saying Docker run down there, and I'm going to give my running version of my container a name. If I don't, Docker just creates these, although hilarious names, slightly awkward names to work with. So I'm going to call it diabetes. And I'm going to say, I want you to run on port 5071 by applying the port and just doing some port forwarding, okay? And so what we should have now is we get a little GUID back that will show us that we've got a running version of our container. If we were to have a look at Docker PS, what we should be able to see is that we've got a container running, which is our diabetes image, and it's running this Python app.py, and it's been up for 37 seconds, right? So what we should be able to do now is come back over here and try and now do our train. And so now what we're able to do is we've got this now running, but it's not running on my local version of Python anymore. It's running on an encapsulated environment using Docker. And so this is all should all work as well. We should now be able to score. And again, in the same way, it's all just working, but now running entirely through Docker rather than my local machine. So we know that this is working. The problem that we now still have, right, is I don't want this to run on my local machine. We need this to run somewhere else. And so this is where we're going to start leaning on Kubernetes to enable us to do that. And to get this to work, we need a couple of different things that we haven't necessarily looked at right now. So I'm going to hop over into Azure, and we'll have a look through a couple of bits. So I've got a resource group here, and I've created two different services. So I've created these two services down here, a running instance of Kubernetes, and an instance of Azure Container Registry. And I want this container registry to provide me my own kind of private area that I can build my images and push them up. So what we're going to look to do is we're going to look to push an image from my local machine up into this container registry, and then ask Kubernetes to go and read that image, get it running, and get it deployed so that we've got a public IP address that we can then use to score our model. And so they're the few bits we're going to look at now. So zoom out of here. Okay. So in order to get a model up into our container registry, first we need to create it, and then we need to log in via something like the Azure CLI or via PowerShell. So the Azure CLI, if you've never looked at it before, can just be installed into a Python window such as this. And it looks a little bit like this, right? If you type in AZ, what you'll get is a number of options about how you can interact with various different services. have a look at here. We've got things for machine learning. You've got stuff right there for Postgres, for Redis, etc. And then we also have one up here, which is ACR. And that's what we're going to use, it says here, right, to manage private repositories and private registries for Azure Container Registry. And then we've also got the AKS service down here as well for interacting with the Kubernetes service. So what we would need to do is we would need to log into our version of Container Registry. Let me grab that. We just need in this window. We need something that looks a bit like this, okay? So we want to say AZACR login, and then I'll give the name of our container registry. And what that enables us to do is create a nice secure tunnel between my local machine and Azure. And once we're all logged in, we should be able to start tagging an image, which is what we need to do to push that to our container registry. So it says here that we've logged in successfully. And what I'm going to do is just clear down any existing repositories inside here. I've got one already. I'm just going to delete that one. And we don't have anything there. So the first thing that we need to do is we need to tag the version of our model which is running locally. So what I'm going to do is I'm going to say down here, I'm going to say Docker tag. Let's just grab that one. Down here. I'm going to say Docker tag diabetes, and I'm going to give it the path of where that model needs to go, which is our sample ACR .azurecr.io, which is the location. And I'm going to say I want you to call it diabetes, and I want you to give it the tag of 1. If I don't give it a tag, it's just going to provide the latest tag. But I want to try to specify this as being just, right, this is version 1. As I go through version 2, 3, 4, 5, I want to keep all of those versions, but I want a bit of control over what I'm working with. So I'm going to tag that. Now if we run Docker images again, what you'll be able to see is we should have our diabetes, which is our top one. But we also have this now ACR sample 2 and our tag here. But what you'll be able to see is that the image ID behind them, they're all the same, right? Because they're just the same thing inheriting one from the other. And what I'm able to do is just say, I would like Docker to push that, and it will begin pushing this from my local machine up into Azure. So again, what you should be able to see here is each one of these coming through. They're slowly being pushed up. And we've got one that's quite big, or one that's almost 400 megs. Takes a little bit of time to push that up. But each part of our image is slowly being pushed up into Azure. So take a little bit of time over my signal. But what we'll start looking at while that's going up is then how we can get Kubernetes to start helping us. So with Kubernetes, we need a YAML file, which is going to describe how our service works. So I've created a YAML file already, which is very similar to the one that we looked at. But what it's saying here is I want you to go away to that container registry, and which is at the same thing, right, the sample ACR, and take the diabetes and take version 1 of that diabetes model. I want you to apply a couple of limits in terms of the memory. And I want you to run on this container port 5071, which I'm going to call Docker port. I've got all of my metadata and application relating to my diabetes model, and I've got everything in a very consistent way. And then down here, the last part I've got is a load balancer. Because what we need with Kubernetes is we don't want to have to worry about wondering, you know, if a pod dies and that has its own IP address, when that goes and we bring something else up, we don't want to have to manage the internals of knowing which IP address we're looking at. We just want a single IP address for our load balancer and let it worry about all of that traffic. And so we're going to do that with this load balancer service, and that's going to run on port 80. And it's going to run through that target port of port 5071. And so what we're able to do now is, in a similar way, what we should be able to do is log in to our Kubernetes service. Let's have a look here. Let's just check this one's finished. Almost. What we'll be able to do is log into our Kubernetes service and then pass it that YAML file and say, I would like you to deploy this. And then once it gets deployed, what it will do is start bringing up those additional pods, and it will service us an IP address that we can start looking at, and then we can send individual requests to. Right, that's almost there. That looks like it's almost pushed. It's just pushing the last part. So that's all live. If I refresh this now, what we should be able to do, right, is we've got our container registry, and we've got version 1 of our diabetes model. This is all up and running and lovely. Hopping back over to our window here, what I'm going to do is just clear this down quickly. And so if we have a look at our Kubernetes service, if I hop over to services, what you'll see is a number of different services, and one here which is terminating currently, because that's the thing I just triggered it to do via the CLI. And that should have gone pretty much as soon as that finishes. Still going. And that's gone. All of the bits and pieces you see here are just base services that come with Kubernetes. And what we'll do now is we're going to say, right, what I'd like you to do is I would like you to create a Kubernetes image for me. And I'm going to use an apply statement, which is an upsert statement. So as I make changes to this and I want more pods, I can just say keep applying these changes and it will incrementally increase what we're looking at. So if I say apply my production YAML, it's going to go away and it's going to start trying to build out those two services. So it's going to build out that deployment and our load balancer. And if we hop over, or rather if we say kubectl get services, if I spell it right, kubectl get services, what we'll have is we'll have a service which is starting to come up. And you can see there we've got diabetes on our load balancer, and we've got an external IP address. Now the services can take a little bit of time to come up, but hopefully if we check this external IP address, what we'll have is an instance of our running application. And then I'm almost out of time. There's a lot, like getting this stuff deployed can take, it takes quite a few different steps. But let's try and see, train, hopefully it's come up. Hopefully it will come up in a moment. There's quite a lot of stuff to try and get ACR and Kubernetes to work and to connect nicely together. Whilst that is loading, I will finish off my slides and we shall loop back at the end, because I want to give anybody an opportunity to ask any questions. And so just kind of in summary, right, Docker can encapsulate our model into a container. Images are built into containers. Those containers can be run locally, but really we need somewhere else to run this stuff, and that is largely going to be Kubernetes. Okay. So demo it all, which we've just done. And what I would say is that Docker and Kubernetes are fantastic for helping you get stuff into production. However, the skills are quite hard to get hold of, right? When we're looking at data science teams, it's very rare to find data science teams with Docker and Kubernetes experience enough to try and get models deployed, which is typically where we see the kind of role of a machine learning engineer emerge much quicker, who can kind of bridge these two gaps. So that is me. Any questions that anybody has, fire them over, and I will see if my service will actually come up. Does anyone have any questions? Yes, Matthew. Yep. Yep. So Matt's question is, can we kind of bring this all together in CI/CD pipelines? Absolutely, right. It's a really great point. It is kind of where we would look at the next step. Because doing this stuff manually is fine, but ideally we'd have all of this encapsulated in a repo somewhere, and then we just have a nice little build job that builds and pushes our image up, and then applies the Kubernetes image, and then we're live. And so then we can kind of have a service that gets everything deployed, and then any changes that we make, either we can just trigger another build so that gets redeployed via DevOps, or we can have an interface that goes away to go and grab a model from a model registry such as MLflow or Azure ML. So yeah, all good. Mm-hmm. Yeah. Yep. Yep, yep. So Matt's question is around what would we do in terms of monitoring? Would we run it as a central service, or would we add something else? Really depends on what you want from monitoring. So monitoring could mean, right, the service, like how many requests are hitting the service. And with that, we could just look at something like log analytics and integrate that, put some application insights as well, so that we can see what's going to that service. We might actually want to deploy this and then put those APIs behind something like the, oh gosh, what's it called? The Azure service which manages all APIs for you, like an API gateway. So then you get health statistics about how long it's taking for each request to go. But the other side of kind of monitoring machine learning models is actually looking at, well, what requests are hitting that API? What are the parameters that are coming in? And how different are they to the expected parameters that I had or the data that I trained with? And that's a kind of entirely different thing that you would need to bake into the actual API that you're serving so that you're capturing that somewhere if it's worthwhile keeping. But yeah, good point. I'm over time. Any questions from anyone else? Luke. So Luke's question is, what's the benefit of using Kubernetes over something like Azure Functions? Another great question. So functions are fantastic to enable you to kind of encapsulate quite basic models. The problem that you have with functions is because they're serverless, you always have a kind of lead time to kind of get them up and running initially. And then once they're there, they're kind of available. The downside is any time that you need a more secure environment and you need to put something like a function inside a virtual network, you have to fall back to reserved capacity, and it is bloody expensive. And so whenever you're looking at something like that, you need to kind of weigh up, like, how serious is this model? How load balanced do I need it to be? Like, am I potentially putting this behind a few 100,000 requests a minute? An Azure function would not be potentially suitable for that scale. Having the more control with Kubernetes would be far more appropriate for that kind of scenario. But it just kind of depends. A lot of models are absolutely fine and really suitable in terms of just putting them inside a function. Cool. They're trying to make me stop talking, but it's fine. I'm going to keep going. Sorry, Richard. Yeah. What's going on? Okay. Anyone online, I will answer your questions in a moment. We don't want to miss the raffle draws as well. So we'll do the two last questions. So Matt? Yeah, yep. So when you want Kubernetes kind of authentication, the options that you have are you can put Kubernetes inside a virtual network so that you're ensuring that any traffic going to that is also going through a reserved set of IP addresses, or you would put another service in there which enabled for authentication. So either way works, just kind of depends on what you need. But typically we would want another service potentially providing that, such as something like an API gateway, to kind of maintain that in a more consistent way. Because kind of managing it like piece by piece on each model could be quite problematic, but having a central service for that gateway would work a lot better. And then there's a question behind Matt. Hey. How does this compare to Databricks? A question is, how does it compare to Databricks? So Databricks have, I'm assuming via MLflow, have their own ability to service a REST API. So at the moment through Databricks, it's very nice, and you can kind of just go click, 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 and you've got a nice API service available. You're very limited in terms of scale. So you can't say to Databricks, what I want you to do is run on this bigger machine, and I want 100 copies of it. It will just create you a single machine which is running as part of that service. So you're quite limited. Databricks is great for kind of POCs, spin up an API and see if there's value there. I think that's a fantastic use case. But for more production, rolling back to something like Kubernetes is just going to be more beneficial. But yeah, great questions. Right, I broke Kubernetes. It's not working for some reason. It's probably authentication. So But yeah, thank you very much for your time. Enjoy the rest of your SQL bits. We will be over on the stand, and if anybody wants to see it working, I will make it work, and you can have a look on the stand. But thank you very much for your time, and enjoy your SQL bits.